Hello everyone, my name is Martin Hendry and I would like to thank the organisers for the opportunity to speak in this session, in which I'm going to talk about ways to engage students with the exciting new field of gravitational wave astronomy. I'm Professor of Gravitational Astrophysics and Cosmology at the University of Glasgow, and I'm a senior member of the LIGO Scientific Collaboration, for which I have led the LSC's Communication and Education Division since 2017. Now, the theme of this session on gravitational waves, black hole shadows, and exoplanets, can we make a place for cutting-edge results in schools? That theme also relates closely to other work I have been leading over the past decade to support the inclusion of modern astrophysics content in the National Physics Curriculum in Scotland. I'm presenting those Scottish developments in an invited talk in another session at this meeting. But in this very short talk, instead I'm going to highlight the gravitational waves education and outreach work undertaken by LIGO, Virgo and KAGRA. I'm not formally representing those collaborations. I'm just speaking from a personal perspective, but of course that is informed by my leadership role in EPO within the LSC over the last few years. Now, in September 2015, we made the first ever direct detection of gravitational waves from colliding black holes more than 1 billion light years away. And since then, the number of confirmed detections has grown to nearly 100, and our discoveries are bringing critical new insights to cosmology, astrophysics, and fundamental physics. But since long before the first detection, education and outreach has been a core part of the LSC's mission. You can read more about our strategic goals in the area of education and outreach in this white paper. It's available on the LIGO website, it's updated regularly, and there's a new version coming soon. And we seek in that white paper to reflect both the rapid development of our field and the exciting outreach challenges that lie ahead. So together with Virgo and KAGRA, the LSC oversees a vast range of education and outreach activities across the globe, online and face-to-face, engaging with formal and informal learners, exploring both gravitational wave science and the remarkable technology that underpins it. Here, I just want to mention a few highlights that offer specific opportunities for high school students and teachers to engage with their discoveries. And you can find out more about these highlights and all the other educational activities and resources listed on the previous slide on our LIGO.org website, and also on the websites of Virgo and KAGRA. There's a section on the websites with resources about our gravitational wave detections, for example, including a link to the Gravitational Wave Open Science Centre that I'll come back to shortly. And there's also a student and educator focus section called Our Science Explained. You'll also find on the website a link to our LIGO magazine, which has been produced twice yearly since 2012 and contains lots of articles aimed at a general audience. And these describe not just the science that we do, but also the stories of the people that make it all possible. So here's a few examples of multimedia resources from our detections page. These were created for announcing the discoveries made in our third observing run, which ran from April 2019 to March 2020. There are animations, sky maps, visualizations, infographics, fact sheets, and lots more. While some of these resources have been produced by professional graphic artists, many have been directly created by LIGO, Virgo, and KAGRA scientists themselves, including many of our graduate students, and they were designed to be used in an educational setting. Another flagship project has been our science summaries. These are non-technical articles that accompany every one of our collaboration papers. They're written by the same scientists who lead the writing of the papers themselves, and are again aimed at a general audience, high school students, teachers, journalists, as well as other astronomers. We always seek to relate the content of our science summaries to the kinds of topics that high school physics students will be learning about, so that they can see the connections between their syllabus and our discoveries. We've produced over 160 summaries to date, with their bespoke translation another global team effort. But let me move now on to the Gravitational Wave Open Science Centre. The EPO teams across the LVK help to support and promote this. It's maintained by the collaborations, and you can find there the actual data from our observing runs, together with tutorials and programming tools to help you analyse the detections for yourself. Now, over the past few years, the GWOSC team has run several workshops, both in person and online, to explain how to analyse our data. These have been attended by thousands of students to date, and the most recent such workshop is still available to be taken as an online course. So while the workshops have been very popular and perfectly accessible to college students, a key future goal is to create GWOSC tutorials that are tailored for high school students and teachers, specifically without requiring any prior programming experience. And to kickstart this, our Caltech colleague Jonah Canner has recently created on the GWOSC pages a learning path aimed at high school students and teachers that complements the other GWOSC tools and workshops you can find there. So let me briefly take you through the steps on the path. It begins with 2 short introductory videos. The first is on how gravitational waves are created and measured, and then the second is more specifically on how we can use the properties of a gravitational wave signal to measure the mass and distance of the source that produced it. Next, students use a simple interactive tool that was developed by our Cardiff LSC colleague Chris North to learn about the basic ideas of waveform fitting and matched filtering. And students can then dive a little deeper into the science behind our waveforms themselves and what they can tell us, drawing heavily on analogies with musical frequencies and harmonies. Next, they learn about signal processing and filtering to help them find a secret sound hidden in noisy data. And then the final steps of the path use a simple graphical interface called QuickView to plot and explore real gravitational wave data. And finally, there's a list of follow-up resources students and teachers can use to explore further. So to summarise, I believe there really are some excellent resources available to help high school students and teachers learn about our gravitational wave discoveries, including interactive tools to let them explore the data for themselves. There are also multiple ways for students and teachers to reach out to us and ask questions. For example, there's the recently set up Gravitational Wave Community Forum, ask.igwin.org, or you can also contact us at the email address question@ligo.org. And another good way to reach out is via our social media platforms. On this slide, you can see contact details for Twitter, Facebook, Instagram, and YouTube listed for all of our collaborations. That's LIGO, Virgo, and KAGRA. And sometimes we operate those platforms jointly, other times separately. So while our detectors have been offline, undergoing further upgrades since 2020, we're set to begin taking data again around spring 2023. That's when we will begin a year-long 4th observing run, and it promises to see even higher detection rates and lots more discoveries. So for me, the promise beyond that is even more exciting. That's when we have the prospect of an expanded and even more sensitive global network of detectors involving LIGO India from the late 2020s, and then looking ahead to the 2030s, a 3rd generation network involving projects which are in the early stages, but are referred to as the Einstein Telescope in Europe and Cosmic Explorer in the US. So I think there's never been a better time for students and teachers to get involved in this exciting new field, and I hope some of the ways I've highlighted by which you can get involved are useful. Thank you very much.